Okay, this is 2.5, lesson 3. This is the third section of this same 2.5, okay? And the title for today is the quadratic formula, all right? In case you're not here today, you just missed a fantastic, choral exhibition. I could not sing it. There's a song that goes with this particular formula. It's in the playlist on the YouTube. So if you're absent, check out that song. It's Pop Goes the Weasel, and it will help you remember the quadratic formula. Okay? One of the most useful things about the quadratic formula, okay, everybody hear me. This works every single time. When we're solving quadratic equations, this method works every single time. We learned at the beginning of this section that by far the easiest way to solve quadratic equations is by factoring, right? Then we learned that there's sometimes when they don't factor. So if that's the case, we could complete the square. Completing the square works every time. It's nice. It's a process that requires a little bit more intuition. Okay, you are going to be tested over it. I do expect you to have learned it. I expect that if you're in an ACT or SAT situation, very few of you would remember that process and be able to use it on that.
I don't know if I'm going to take those after yesterday.
Okay, so I want you to know how to complete the square. I want you to know that that is a very useful tool. I think that you can perform it, right? But again, given a crunch time situation, I don't know that you're going to come up with it. So I want to teach you the quadratic formula. If you have found yourself in a place, which none of you have by now, that you can't factor, right? If factoring's just not in your wheelhouse. I used to teach this to kiddos who never learned to factor. Just never could understand, never could get it down. They could do this thing every single time, okay? It's super useful. However, it's a little bit more tedious. And so some of you are going to look at this and say, no thanks. I'll pass. I'll learn how to factor and life will be good. Okay? In the event that you can't factor and you don't remember how to complete the square, this works. Okay? You got 3 steps. 1, you need to write your equation down. So if you don't have this on your paper right now, put it. This is called the quadratic formula. The quadratic formula. And it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, if you're not singing that in your head as you're writing it down, you need to go back and watch the video.
Yeah, progressing each way again.
And so this is saying you're going to have a quadratic equation and you are trying to solve for the values of x that would make your quadratic equation equal 0. In other words, you're looking for x-intercepts or zeros or roots. Same thing we've been doing all week long. Okay? You've got 3 things that have to happen here. Maybe 4. 1, you need to write the quadratic equation in standard form. Write the quadratic equation in standard form. That is ax squared plus bx plus c equals 0. You got to put them in order. Ax squared plus bx plus c equals 0. Okay, that's got to happen. Step 2, once it's written like that, you need to identify A, B, and C. Identify A, B, and C. So you're going to pull those values directly off of your standard form equation. Remember that A and B are coefficients of the x terms, not including x, just the numbers in front. Okay. After you've identified A, B, and C, you're literally going to plug into the formula. Plug into the quadratic formula. I want you to write this because it's very important. This is how you keep from making big mistakes. Use parentheses around every letter. Use parentheses around every letter. So every time I'm about to plug in for a new A, B, or C, I'm going to open up parentheses. That's going to keep your signs from getting wonky. Okay? One little bitty sign error will make you miss the whole problem. And then the last thing, after you have it all plugged in, you're going to solve. You have to calculate both the plus and the minus. Calculate both plus and minus options. Remember, we're going to have two answers here. And in this formula, it says plus or minus the square root. The plus or the minus means I have two answers. We're going to calculate one with the plus sign and one with the minus sign. Good? Questions so far? I'm going to see it in action. All right. So here comes example 9. Example 9. Promise we're going to finish this section. It says x squared plus 5x plus 1 is equal to 0. And our instructions are solve. Solve for x. Okay. It's already in standard form. It cannot be factored. There are no factors of 1 that make 5. Okay? So it can't. Why can't you? You could. So the question is, why can't we complete the square like we did yesterday? You could. You could. The issue here with that is if you weren't so close to what we did yesterday, you will have forgotten how to do that. Chances are. Okay, I'm gonna take a bet that later years from now, like if you're sitting in a ACT in July this coming summer,
Remember the song.
You are gonna remember the song. I promise. I added it to your playlist. Okay, so yeah, you could complete the square, and I expect you to know how to do that. Okay, but I'm trying to put more tools in your toolbox so that you could pull out whatever option works for you on the given day of your test. Okay. So step 1, write it in standard form. We did that. Step 2, identify A, B, and C. Once it's in standard form, you can tell. What's A? 1. I love how you didn't say x squared. We're looking at the number in front of x squared, which happens to be 1. B is 5. C is 1. Once you've got it, all you have to do now is plug in. I want you to write the equation every time. X is equal to, you should sing the song, negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to write it down. Otherwise, how do you know what you're plugging in? You following? So now we're ready to plug in. X is equal to negative, and then we're going to open parentheses here. Every single time I'm plugging in for a letter, I'm going to open parentheses. So negative, open parentheses, 5, plus or minus the square root, open parentheses, 5, and then we're going to put squared, minus 4. You don't have to open parentheses on the 4. It's going to be minus 4 every time. But then we're going to open parentheses because we're plugging in for A is 1 and C is 1. And then we have at the bottom all over 2, open parentheses, and a 1. Okay? Guys, you're going to think at this point that the parentheses don't matter. Throw a negative in there and you'll see that they do. Okay? Every time I square a negative, that comes out positive. If I don't put the parentheses, I don't catch it. Huge issues happen when we don't use our parentheses. Now, all we have to do is simplify. So x is equal to negative 5 plus or minus the square root. I've got 5 squared, you said, is 25. 25 minus 4 times 1 times 1 is 4. All over 2. So far, so good? So we have negative 5 plus or minus the square root of 21 over 2. 25 minus 4, 21. Now, is 21 a perfect square? No. Is there anything I can pull out of there? 21 would be like 7 and 3. Those are both prime. So I can't simplify that any further. At this point, you would, if you had to get a decimal answer, you would go to your calculator. Okay? If you have a calculator on you right now, let's get it.
What if you usually just a square root 25 and then square root 4?
No, because there's no rule for square rooting a difference. There's no rule for that. The rule that you're thinking of is the square root of a product, in which case you can do the square root of A times the square root of B. But that's only if they're being multiplied. That rule doesn't work if they're being added or subtracted. Okay? Good question. Good question. At this point, we're going to put it on our calculator, and I want you to practice, and I'm going to put it on this screen. I want you to get out your calculator so that you can see exactly what we would need to type. I want you to notice, as you're typing this on your home screen, how many parentheses I have up here. Right? Negative 5. I did put the negative in parentheses with the 5. That's a typo on my part. It didn't actually change the function. But you should have negative and then your 5 inside parentheses.
What do we round to?
So what do we round to? I usually go to the nearest hundredth. Negative 0.21 would be an answer. Also notice right here that we have 2 different calculations. You're going to have 2 different calculations on your screen. You'll have one calculation where you're adding the square root stuff. You will have an entirely separate calculation where you're subtracting the square root stuff. You could type the whole enchilada in your calculator. You just have to use parentheses. That's what I'm saying. Like, when I get to my wit's end with a kid, if not you guys are honors level and y'all are rocking and rolling. But if I was trying to teach a kid who I knew had no prayer of actually knowing how to factor or actually understanding completing the square, I would just teach them to use this formula. Anybody can plug and chug. And it's useful and it works every time. So you just have to know the formula, hence the song, and you have to be able to plug into it. After that, you get your answers every single time. All over 2A.
You're laughing, what's going to say you want to test?
I know it's going to save me. I'm just laughing.
Well, what's interesting is that, like, my kiddos in pre-cal, anytime we have to use this, or physics, we have to use the quadratic equation quite often in physics, because we'll be trying to figure out when is a ball landing, right? So we've got this quadratic expression, and we've got to find the zeros, and it's a real life function. They're not pretty. They're not ever factorable. So we have to use the quadratic equation to find the time. Well, it's been my seniors that haven't sat in this classroom since they were sophomores, and they have to come back and they sing the song. That's how we remember what we're doing. We get numbers? Did y'all get my numbers?
Yeah.
The same thing exactly like that says? Remember, you have to do it separately, the plus option and the minus option, in 2 different calculations. Okay?
Yeah, calculator just stops after a certain point with the numbers.
Yeah, for sure. And your calculator is not able to handle plus and minus at the same time. So understand that and separate them when you need to. All right, let's go on. Any questions on this one? Okay. Huh? A lot of questions? Any I can answer? Okay. All right, so here comes number 10. This is going to be number 10. And I don't know why I'm at, this happens sometimes. Yeah, example 10. This is example 10. And it says x squared plus x plus 2 equals 0. And our instructions, again, are so very clear. Solve. Solve. And so, again, factors of 2 that would make 1. That would make a 1, positive 2. So either they're both negative, negative 2 and negative 1, or they're both positive, positive 2 and positive 1, and neither one of those make a 1. Okay? So factoring at this point is not an option. Okay? Can't factor. Yes, we could complete the square. No, we're not going to do it for this particular problem. Mason said it's already in standard form. So what do we have to do next? Identify A and B and C. What's A? 1. And B is 1. And C is? Okay. And now we're going to plug in. And how does it go? No, remember? X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. The slower you do it, the creepier it is. You have to imagine like a puppet. Da, 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 da. It's awful. It's awful. Yeah. All right, so now we're plugging in negative 1 in parentheses plus or minus the square root of 1 squared minus 4 times 1 times 2 all over 2 times 1. Check your work. Nah, you're going to listen to it in the car. It's fine.
I'll make a TikTok about it later.
Negative 1 plus or minus the square root of 1 minus, what's 4 times 1 times 2? 8. All over 2. Huh. So negative 1 plus or minus the square root of negative 7 minus over 2, all over 2. Put it on your calculator. You know? Do you see the problem? Do you see the problem?
No real calculation.
No real calculations.
Imaginary.
Non-real number. It's imaginary. Why? Why is it imaginary? Because you can't square root a negative. Imagine.
So would it be I?
Yeah, so our only option at this point is to simplify. X is going to equal negative 1 plus or minus I square root 7 over 2. So sometimes that's going to happen to you. And you're going to type it exactly like it says. And when your answer says non-real answer, first thing you're going to do is check your parentheses and make sure you didn't miss any signs. Because you could have made a mistake and that would yield the same result. But if you know for sure, I didn't mess up, then the best you can do at this point is simplify. And you're going to let that negative come out as I. Okay? So what does this look like on a graph? Why did they show up imaginary?
Is it a solution?
Yeah, here we go. This is our picture. X squared plus x plus 2 equals 0. Well, guess what? Here's the x-axis. Here's my function. It's well above the x-axis. So there are no real roots. Can you tell that? Any questions on why that just happened? Okay, so if you got numbers, even if they were decimal numbers, that means your function crosses the x-axis. If you end up with imaginary solutions, that means it does not. There is a way to tell if that's going to happen or not. Okay, there is a way. Look back at your quadratic equation. This is the quadratic formula. If you're looking at this function, does anybody know how you can tell whether or not your solutions are going to be real or whether they're going to be imaginary? If what?
The A or C is negative.
Okay, if the A or C is negative, I may be adding or subtracting from B squared.
B smaller than the product of 4AC.
Okay, if B squared happens to be smaller than the product of 4AC, that's awesome. That's a really great thought. Here's something that's a lot simpler, okay? When we look at the quadratic equation, we can tell if it's going to be positive or negative. Well, that went badly. If we look only at this piece under the square root sign, okay? If you just look at the piece under the square root sign, you can tell whether or not your function is going to have real solutions or imaginary solutions or only one solution. That piece underneath there is called the discriminant. The discriminant, okay? So write this down. Quit. Stop this. Why? The discriminant, this is how you spell it. discriminant. The discriminant is the expression under the radical sign in the quadratic formula. It's the expression under the quadratic sign, or under the radical sign in the quadratic formula. It's this portion right here. B squared minus 4AC. Okay? B squared minus 4AC. That's the discriminant. And why is it so important? It tells us whether the solutions are real or complex, and how many solutions to expect. How many solutions to expect. It tells us whether the solutions are real or complex and how many solutions we can expect. Okay? We got about 9 minutes to wrap this up, so let's boogie. It tells us whether the solutions are real or complex and then how many of each kind we're going to get. Y'all ready? How many to expect? This is going to be example 11, and it's the last one. Okay. Before we do example 11, we're going to write down some rules for the discriminant. You ready? Everybody good? Okay. So the first rule is this. If b squared minus 4ac equals 0, b squared minus 4ac equals 0, can I take the square root of 0?
No.
Yes. What is the square root of 0? 0. So when I add or subtract it, what happens? Nothing. Okay? So this is allowed. It's not complex, but it's going to only yield one real solution. So if your discriminant equals 0, you only get one answer, because whether or not I add or subtract 0 doesn't change my answer. Are y'all with me? How does that look graphically? It means the vertex of the parabola is on the x-axis. Whether it opens up or down, the vertex touches the x-axis. Okay? Okay, now what if my discriminant, the stuff under the square root sign, is greater than 0? Can I take the square root of a positive number? Can I take the square root of a positive number? In which case, I'm going to add and subtract. So how many solutions am I going to have here? 2. And they're going to be real. 2 real solutions. That's going to look graphically like my parabola crosses the x-axis in 2 places. Two real solutions. The third and final option here, b squared minus 4ac, is less than 0. What kind of number is less than 0? Negative. Here I can't take the square root of a negative number. So how did these come out? Not real. So we're going to say there are 2 complex solutions. And you saw that on number 10. We still had plus or minus I square root 7. We still had both the positive and the negative option. They're just complex, so you don't see them. Okay? So what does that look like graphically? Probably my parabola is below or all above the x-axis. It doesn't come anywhere near it. All right, let's hit example 11. Let's try to finish before we get out of here. Example 11. It says use the discriminant to determine the nature of the solutions. Use the discriminant to determine the nature of the solutions. So for part A, our problem says x plus 4x plus 4 equals 0. We want to plug into the discriminant, which says what? B squared minus 4ac. When we plug in the 4. 4 squared minus 4 times 1 times 4. So I've got 16 minus 16, which is 0. So how many solutions am I going to have? The discriminant equals 0. So that's going to be 1 real solution. Good. If you're not sure, look back at your notes. We just wrote that down. Y'all seeing it? Okay. You don't have to find where it is. The question is, how many does it have?
So it just that's the solution?
1 real solution.
No, 16 minus 16 equals 0 is the solution.
Because the discriminant equaled 0, there's only 1 solution. Letter B says 8x squared plus 14x plus 3 equals 0. So again, we're going to plug into the discriminant, b squared minus 4ac. So 14 squared minus 4 times 8 times 3. If you're not sure, 14 squared is 196. We got 32 times 3, 96. So we got 100. How does 100 compare with 0? It's greater than 0. So 2 real solutions. 2 real solutions. Good? Okay. I'm going to skip part C. It also had 2 real solutions. Let's look at part D. Part D, it says 3x squared minus 10x plus 15 equals 0. We're plugging into b squared minus 4ac. Again, the need for parentheses here is astounding. Negative 10 squared makes positive 100, y'all. Be careful. Negative 10 squared is going to be positive 100 minus 4 times 3 is 12. 12 times 15. Anybody got that real quick?
180.
Nope. 12 by 15.
180.
Yeah, it's 180.
Is it 180?
180. 180.
Okay. I got 300. Well, that's fine. It's fine. This is on YouTube. It's great. 100 minus 180?
Negative 80.
Negative 80. How does negative 80 compare with 0?
No.
It's less than 0. So we don't have any real solutions, but we have
2 complete.
2 complex solutions. Try your homework tonight, guys.
Golly.
Golly.
Yeah, I'm not doing it. What's homework?